The Physics of Golf Senior Project by Mac Mackey, Thomas DeFranco, and Kevin Merck, Period 4. As you may or may not know, golf can be a very frustrating game. People all around the world and of all ages have spent years trying to master this difficult game. Mark Twain once said that golf is a good walk spoiled. However, the game becomes much easier once one understands the physics behind the game.
We decided to highlight 4 key elements to the physics behind the game of golf. The elements are as follows: kinetic energy, potential energy, momentum, and impulse.
First, we decided to go over the kinetic energy in the game of golf. Here we will watch Kevin Merck try to hit his driver. As Kevin hits the ball, he is exerting a hitting force on the ball. This gives rise to the ball's kinetic energy. The equation for kinetic energy is Ke equals 1/2 mv squared. M represents the mass of the ball in kilograms, and v equals velocity of the ball in meters per second squared. We found that the mass of the ball is equal to 0.0459 kilograms, and that the velocity of the ball is 65.7149 meters per second squared. This gives us the equation Ke equals 1/2 times 0.0459 times 65.7149 squared. This gave us a total kinetic energy of 99.108 joules. This is a simulation of Kevin's driver swing, which he sliced a little bit to the right.
Next, we decided to analyze the potential energy of the golf ball at its apex.
As the ball reaches its apex, it gathers the most potential energy. The equation for potential energy is Pe equals mgh. M represents the mass of the golf ball in kilograms, g represents gravity, and h equals the height in meters. This gave us the equation Pe equals 0.0459 times 10 times 42.7. This gave us a total potential energy of the ball at its apex of 19.5993 joules.
Here you see the ball reach its apex, where it achieves its greatest potential energy of 19.6 joules.
The next element we decided to analyze was the momentum of the golf club.
Here we will analyze the momentum of Kevin's driver swing. The momentum of the club head. Momentum equals P equals mv, or pmv, where P is momentum, m is the mass of the club in kilograms, and v is the velocity of the club. Here in this equation, P equals 0.274 kilograms times 46.83 meters per second. Here in this equation, momentum equals 12.83142 kilograms per meter second.
Here we are looking at the impulse of the golf ball.
Here we will analyze the impulse of the golf ball. Impulse is equal to the change in momentum. We know that P can stand to equal momentum. Thus, impulse is equal to Pf minus Pi, which stands for final momentum minus initial momentum. In this equation, P is equal to mv, or mass times velocity. M represents the mass of the golf ball in kilograms, and v equals velocity of the ball. In this equation, Pi, or initial momentum, is equal to 0.0459 times 0, which equals 0, and the final momentum is equal to 0.0459 times 59.43, which equals 2.72. Thus, the impulse is equal to 2.72 kilogram meters per second.
In this clip, Tiger Woods will show us an example of a perfect golf shot. It displays momentum, impulse, kinetic energy, and potential energy. Thank you for watching, and we hoped you learn a bit about the physics of golf.